Hello, we are from the third group. We are going to explain about inferential statistics. This talk is from our lecturer, Dr. Pil Maria Theodora Ting. From this talk, the first speaker will be delivered by Jihan Salsabila Wahyuni. The second, Nopyta Lutvi Pratiwi. Third will be me, Widya Pertiwi. Fourth, Bain. And the last one, Haris Maulana.
Inferential statistics deals with inference about population based on the behavior of samples, concerned with determining how likely is it that result based on a sample or samples are the same result that would have been obtained for the entire population. Standard error. Standard sample error, expected change, variation among the means, a difference found among the sample means, whether it is a result of sampling error or a reflection of a true difference normally distributed. The null hypothesis. The null hypothesis says that there is no true difference or relationship between parameters in the population and that any differences or relationship found for the samples is the result of sampling error. Nullify the research hypothesis. The null hypothesis continue, rejected or not rejected by using the test of significance, a probability level which indicates how much risk we are willing to take that the decision we make is wrong is needed. Level of significance, the probability in which the researcher will accept or reject the hypothesis. Test of significance, the decide whether we can reject the null hypothesis made at a pre-select probability level. Factors such as the measurement scale, method of subject selection, the number of groups, and the number of independent variables determine the test of significance to be used for a particular experiment. And then types of inferential statistics. First is t-test, second is ANOVA, ANCOVA, MANOVA, and last is non-parametric test.
ANOVA. ANOVA short of analysis of variance. ANOVA is a perfectly descriptive name of what is actually done to analyze sample data acquired to answer problem. ANOVA explain about what you want to describe. For example, we describe about qualitative. That means what we talk about is qualitative. This ANOVA analyze the sample to get answer. The function ANOVA is to decide the effect one or more independent variable to one dependent variable. There are two types of ANOVA, one way and two way. One way just explain about a solve factor or a solve response. That means the response of the sample are the same. And the second two way. Two way is comparing the result of independent and dependent variable. Hypothesis testing. Hypothesis testing consists of two. HO for nil hypothesis and HA alternative hypothesis. HO, the population means of all groups under consideration are equal, and HA, the pop means are not all equal. For formula of ANOVA, first notation, and the second splitting the total variability into parts.
In this case, I will explain about t-test. As we know, we use t-test in research, for example, for cause-effect research design. T-test is to compare between one sample to another sample from a test. T-test means to analyze two samples and two population means through the way of statistical examination. There is the function of t-test. The function of t-test to compare a sample to know the population mean. When you want to, like for example, when you want to find the effect of your research, you use t-test to compare the test to get the result. There are three types of t-tests: one sample t-test, pair t-test, and independent sample t-test. One sample t-test is one-way sample, which is when you like in the classroom, you want to test in the classroom. The classroom is only one classroom and only one test to get the result. While pair sample t-test is from two classroom that has average skill. Bain test, they got test, and they got test to get the result. And the last one, independent t-test. Independent t-test is two-way t-test, which from two class, random class with average skill, they get test to get the effect or the result.
I will explain about ANCOVA. What is ANCOVA? ANCOVA is analysis of covariance. Analysis of covariance is an extension of ANOVA that provides a way of statistically controlling the linear effect of variable one does not want to examine in the study and controlling the effects. And controlling the effects of continuous or scale variables that you are concerned about, but that are not the focal point of independence variable in the study. The extraneous variable are called covariates or control variable. The independent variable is nominal, categorical, and the dependent variable is interval, continuous. And then the functions of ANCOVA. The functions of ANCOVA consist of three things, or we can use ANCOVA in three design. The first is in experimental design. In experimental design, we can use ANCOVA to control for factors which cannot be randomized but which can be measured on interval scale. And for the second, in observational design, we can use ANCOVA to remove the effects of variables which modify the relationship of categorical independence to the interval dependence. And the last, in the regression models, we can use ANCOVA to fit regressions where there are both categorical and interval independence. It consists of two before the structure force has become displaced by logistic regression and other methods. And for type of ANCOVA only have one type. That's one-way analysis of covariance. One-way analysis of covariance evaluates whether population means on the dependent variables are the same across levels of a factor independent variable, adjusting for differences of covariate, or more simply stated, whether the adjust group means differ significantly from each other. And for formula of ANCOVA, we can see, okay, I will explain it. The test statistic for ANCOVA, we can symbolize F, is the ratio of adjust between groups MSB, mean squares, between group mean squares, to the adjust within group means MSY, and this is the summary table for one-way ANCOVA. consists of source from covariate between within and below, as you can see it. And for hypothesis testing, the null hypothesis and alternative hypothesis for ANCOVA are similar for those for ANOVA before. Conceptually, however, these population means have been adjusted for covariate. Thus, in reality, the null hypothesis of ANCOVA is of no difference among the adjusted population means, and this is the symbol or formula for hypothesis, null hypothesis, and alternative hypothesis.
MANOVA. Multivariate analysis of variance or MANOVA is simply an ANOVA with several dependent variables. That is to say, ANOVA tests for the differences in means between two or more groups, while MANOVA tests for the difference in two or more factor of means. The function of ANOVA. The major purpose of multivariate analysis of variance is to determine the effects of one or more independent variable upon more than one dependent variable. MANOVA is useful in experimental situations where at least some of the independent variables are manipulated. There are 4 different test statistics based on the MANOVA tables: Width lambda, Hotelling Lowly trace, Pillai trace, Roy's maximum root. MANOVA tests are made on h equal e minus 1 h, but there are 4 different multivariate tests that are made on h minus a minus 1 h. Each of the 4 test statistics has its own associated F ratio. In some cases, the 4 tests give an exact F ratio for testing the null hypothesis, and in other cases, the F ratio is approximated.
Okay, I will explain about non-parametric statistics. A parametric statistical model is a model where the joint distribution of observations involves several unknown constants called parameter. And the next is the function of non-parametric statistic. The function or form of the joint distribution is assumed to be known, and the only unknowns in the model are the parameters. The types of non-parametric statistics. It consists of 2 types. The first is a non-parametric model, and the second is a semi-parametric model. A non-parametric model is the one in which no assumption is made about functional form of the joint distribution. The only assumption made about the observation is that they are independent, identically distributed from an arbitrary continuous distribution. As a result, the non-parametric statistics is also called distribution-free statistics. There are no parameters in non-parametric models. And the second type is a semi-parametric model. A semi-parametric model is the one which has parameters but very weak assumption. And this is the formula for semi-parametric. And then for hypothesis test, the level of significance is not sensitive to model assumption. The statistical power of a test to detect important alternative hypothesis is not sensitive to model assumption.